Awesome. Thank you.
No problem.
So, hello everyone. My name is Miguel Matos. I will be your teaching assistant for this workshop alongside Bingyu. Before we start, I wanted to actually introduce myself. So I was born in La Habana, Cuba, and I moved to the United States at a very young age. I began studying civil engineering, but decided to switch to architecture to pursue a more creative career. I then graduated with my bachelor's in architecture and urban planning from the University of Florida and decided to attend the University of Pennsylvania for my master's degree. During Penn, I've had the opportunity to be a teaching assistant for the first and second year of the Master of Architecture program. And more recently, I've had the opportunity to become a part-time lecturer for the Advanced Architectural Design degree as well. I have worked for many different firms, including RSNH in Florida, Hume Architecture in Brooklyn, and Euler Wood Collaborative in Los Angeles. Starting this fall, I will be co-teaching a studio with Ali Rahim, and I'll be moving to New York to work at SOM as a junior architectural designer. That's a little bit about me. If you have any questions, just don't hesitate to ask me about anything. I am here as a resource to all of you guys. Can you guys see the screen perfectly?
Yes.
All right, good. So I would like to start the lecture talking a little bit about history. It's important to understand how the tools of the time kind of like affected the way that society lived at that time, and also the kind of aesthetics. It's important to discuss kind of like the issues of the times and the solutions that those societies found. So for many years, humans lived in caves, limited by the tools of their time. And with time, they began to evolve and to develop new tools that gave them the opportunity to live off hunting, food gathering, and fishing. From the perspective of our advanced world today, we tend to look back at this and wonder, how is it even possible for us to survive during these times, given all the difficulties? The thing is that with the passing of time, humans began to think and act differently than their ancestors. They encountered new issues, and with these new issues, they created new solutions. Forests had to be chopped down, clay had to be fired, granaries had to be established, animals that they needed to be tended to, wool needed to be harvested and made into cloth. Plants that were once considered food were now thought of as weeds that had to be replaced from the gardens. New decisions had to be made about priorities. With these decisions came new approaches and the development of new tools. I think this image is quite interesting because notice how they not only depict the evolution of the human alone, but also the evolution of their tools, which played an important part on our development as a species. This is something that we will discuss today during the lecture. So around 3500 BCE, humans started the process for the development of what we call today's cities. Even though this process was not a linear one, it brought with it the development of new tools and techniques. In Mesopotamia, for example, the farmers used to stay away from the flood-prone swamps near the rivers until one day when evolution required them to relocate to those areas. So they started digging up the reeds, planted barley, and carved out canals. Keep in mind that these were considered activities that were really time-consuming and labor-intensive. But this new approach was a success, and it reinforced the idea that by doing one single thing well, which was growing barley, the inhabitants of an isolated place could start trading for everything that they did not have. So again, this idea that developing new techniques based on their necessities advanced their culture a lot. And again, these are some of the tools they used back in that time. When these tools and the development of new ones, they created the wheel to speed up travel. They created writing to document trade transactions, and they laid the foundations for laws and regulations, as well as they built walls to defend their new economy, their new earnings. So now moving a little bit to India along the Indus River, cities also emerged, but they were different because unlike in Mesopotamia, where the building material was mainly mud dry brick, here the population developed killing fire bricks that could not only last longer, but they also allowed them to build closer to the rivers and to build pools, drainage systems, and multi-story houses. And so these are some of the examples of how a new change in technology again, or a new material, allows a culture to thrive in a different way. And also it kind of changes the aesthetics of that society at the time. So in China, the development of cities also took place, but it was also different. Here, people use a form of architecture called the pit house. It was a typology that consisted of digging partially into the ground with a frame made out of thatch held in place by posts and beams. These collective buildings were dry and warm, and they provided the space for ritual activities. Unlike Mesopotamian cities, which were more like import and export centers, these villages were more self-sustaining, and so they were able to attain the scale of cities very quickly. There was a sense of community in here. So it is important to mention that the manufacturing of pottery and bronze was a big economic element in these villages as well. Egypt developed a clear dynastic power structure and a set of religious traditions from the early ages. Due to the fact that agriculture was a seasonal process, during the rest of the year, pharaohs would summon farm workers as forced laborers for building their projects. Soser's mortuary temple, which was built at a scale unprecedented for that time, is considered one of the first monumental stone buildings in the world. This was due to Egypt's mastery of stone masonry, which was one of their greatest contributions to architecture. And here we can see, a close-up of how perfect these stone blocks were carved, which I think is quite amazing. So pyramids are the last standing elements of an extensive ritual architecture that included temples, causeways, forts, shrines, and special tombs. Again, this reinforces the idea that the tools developed by a specific group in history has always been tied to their cultural practices and needs. When engineers set about to build the Great Pyramid of Khufu, they took no chances and chose a solid rock foundation. Its orientation, so close to the north, has raised questions about how the ancient Egyptians managed to achieve such accuracy. 6 million tons of solid masonry, consisting of 2,300,000 individual stones, rested on that foundation. The core was mostly of yellow limestone gathered from close by. The casing stones were fitted together with such precision, the sides would have been seen smooth under the sun. Egyptians developed mathematics as one of their main tools to control the assembly of these monumental objects. The face of the triangle along the surface intersects the ground at an angle of 51 degrees. This means that the height of the triangle along the surface to the top is related to the golden section. The angles of the internal passages, as well as the location of the various chambers, are also thought to have been defined mathematically. There's also solid evidence that the layout of the three pyramids is not random, but that it too conforms to a unifying geometric plan. Again, another example of how good society continue to develop new methods of construction and assemblies in response to the problems of the time or the cultural necessities, which at the time, again, these solutions were guided by cultural ideas. Even today, archaeologists can only hope to guess how the pyramids were built. So I just have a little video here of like, you know, how do we imagine that this happened? This is a great example of a type of method of assembly so advanced to the time of this society that it is difficult even for our times to comprehend how it was possible. So here's a short video about that. I don't know if you guys can hear the sound, but I just want to show a little bit of how archaeologists imagine that this was recording built. In progress. So
there's no sound, Miguel.
It's okay. I'll talk over it. So this is the way that they imagine. They built this kind of like ramps that then were taken down after the pyramids were done. But there's many other theories about how this was done. And I think it's fascinating the fact that we still don't know how these things were built, but we do know that there was a craftsmanship, like the way that these stones were carved to the edge of it versus the interior of them. There's a craftsmanship like quite excellent in the terms of like how these objects were assembled, right? So again, archaeologists are just like trying to understand this is how it was supposed to look when it had the finished elements on the exterior. With time, it got eroded, or that's what historians believe. And at the top, it had like a golden triangle. So I wanted to show a little bit about that. Then we jump a little bit to the Greek temple design, which it changed considerably in the middle of the 6th century BCE, as wood was increasingly abandoned for stone. This may have been partially due to the desire for permanence, but it may also have been started by the impact of Egyptian architecture, with which the Greeks were really familiar with. This is a great example of how cultures also influence each other when it comes to innovation. So the Greeks began to build factories to produce pottery and ornaments in an Egyptian style to sell in Egyptian markets. Due to this trade, the Greek came into contact with the enormous Egyptian stone temples and pyramids and began studying Egyptian construction techniques. Before this, they were just used to small wooden temples and simple outdoor altars. They had already mastered the use of stone. But to start developing a new typology of columns and even the roof of the colonnade out of stone was a completely new approach to construction. In Greece, stones were brought to the construction site in an almost finished state, whereas in Egypt, stones for columns arrived at the site still quite rough, apart from the horizontal cuts, with most of the finishing taking place when the stones were in situ. This difference would have been significant. It would have a significant impact on Greek architectural developments, as it would allow for an ever-increasing elaboration of detail, proportion, and form. These are some examples of, as we know, the Greek columns and the 3 orders. Then I wanted to jump a little bit to the Renaissance. So the term Renaissance, which means rebirth, was coined in the 19th century to describe the cultural and intellectual advancement that took place in Italy during the 15th century. During this time, the Italians began to uncover and study Roman and Greek texts while trying to relearn what had been lost to Europe in the Middle Ages, and then trying to find ways of applying learning to their own times. And I think this is interesting because this again goes back to the idea that the Italians really studied other cultures and mixed them with their new technologies of their times to come up with their own discoveries in all areas of life, not just design, from mathematics to even psychology. So again, one of the most influential discoveries of this process, for instance, was the discovery of perspective, or actually the notation of it, the appearance of which had been approximated by painters like Giotto di Bondone, or which was first described mathematically by Leon Battista Alberti in 1435. With perspective began the process of locating the human eye both literally and conceptually at the center of our universe, which at the same time led to the European Enlightenment of the 18th century. Another one of the many phenomena from the Renaissance that affected the way that things were put together back then was the fact that the difference between the architect and the craftsman was now present. So it was, nowadays architects most of the time are also considered the craftsmen of the project. So having a deep knowledge of how to put things together now is a big part of how we present our work. So I think that's very important to understand. And so, the previous examples in history reflect how the specific tools of the moment guided the specific cultural, aesthetic, construction methods present at the time. Today, the widespread use of computers have accelerated cultural changes similar to those effects that the Industrial Revolution had back in the days. So from the 1990s, Frank Gehry and Greg Lynn explored the effects of computing technologies on design and architecture. However, at this time, these efforts were still only happening in a small amount and in small academic institutions and architectural offices. It wasn't like a widespread thing. So Frank Gehry and Greg Lynn there, these are examples of their work. This is the Lou Ruvo Center, Frank Gehry, and then this is a competition from 1994, which you can see the similarities, but also the jump in terms of like geometric freedom that now designers have because of the computer. So, and then other softwares like AutoCAD, 3ds Max, and FormZ were starting to be used by architectural offices. But the main thing to notice here is that these softwares were not used for the conception of the project. They were starting to be used as a tool for representation after the design was already conceived or envisioned. Other softwares like CATIA and Rhino were also being used, but limited to curvature analysis and to determine potential bending stress and material strain calculations. Here we can see on the left the original intent for CATIA software, which was for airplane design and just analysis. And on the right, the possibilities of what happens when the right tools fall in the hand of an architect or a designer. Today, architects and designers have embraced these tools as an extension of their own design process. These tools, when they began to be used for their full capabilities, allow for important innovation within our discipline. The expansion of digital architecture definitely benefited from the interest of designers to conquest new forms that were impossible to get before using these new design tools. Like in the historic examples that we talked about, we saw how each time period mixed with their cultural knowledge and their own advancements of the tools of the time. And this at the same time allowed them to develop a specific type of aesthetics. In the same way, we're trying to do the same through this workshop. So how can we push the digital tools that we have now to analyze and transcend our own cultural aesthetics in hopes of developing something that it's familiar, yet strange at the same time. So until the 1990s, sophisticated geometric researches were generally related to the use and misuse of these shapes right here, the paraboloids and the hyperboloids, like those used for concrete shells, tensile structures. The expanded use of computing technologies changed that, and it allowed designers to grow dramatically the range of their formal vocabulary. Now we have the opportunity to develop a process that can potentially yield new aesthetic conditions in combination with our own cultural experiences. So this is just to say like how important, that's what we're pushing for you guys to also choose one of your images to be a cultural experience or that has cultural value to you, because we think this is like one of the good ways of like trying to hybridize our own cultures. So in addition to the many different shapes and forms that are possible now, the most important aspect is that we have the ability now to analyze these forms carefully and in a very short time using computer modeling. This allows us to develop a feedback loop where we now can produce complex forms, but not for the sake of being formal, but to be able to step back and evaluate their qualities, which at the same time refines our own eyes in terms of aesthetics and gives us more control over these new digital tools. This feedback process is essential, and I think this is very important because it is what makes a difference in us accepting what the tools, what the computer gives us versus now analyzing the results and being intentional on how we use these tools and what is produced by them. So this is a very important point that we need to keep in mind, because we're not now slaves to the tools, but now we control them, so we can control the outcome of what we want to produce instead of just accepting what we get, which is what happened in the 90s when computers were used. These are 3 examples from different architecture offices. You can see the kind of like the range of different formal qualities that they can have, but now we can have an opinion, and we can start like looking at forms that we produce to start developing our own aesthetics and our own sensibilities. So that's very important. So nowadays, architecture is able to go much further. These are some drawings by Morphosis. Digital technologies have become a space for designers to develop new techniques, pushing the boundaries of innovation and really creating significant cultural impacts. The technologies of today allows us to tackle complex issues in a 3-dimensional manner. Design is definitely more advanced and more complex than what it was before. Issues of space, programmatic tensions, tectonics, and aesthetics can all be organized in an elegant manner due to these new tools. These are some of the, again, compositions from Morphosis, part drawings, part model. They deal with a multiplicity of systems present in each one of them, and in a certain way present their own disjunctive continuity. This change, of course, is tied to the development of a wide range of geometric modeling techniques. Apart from wireframe and solid modeling, NURBS modeling has allowed for ultimate control of a designer's intention. NURBS stands for non-uniform rational B-splines, and it is mostly this type of modeling that we will be using for this workshop. This type of modeling is available in many softwares like Rhino and Maya, to name a couple. And they allow us to interact with curved surfaces and volumes in a highly intuitive way to generate and visualize objects as if they were in the physical realm. So in this regard, and despite their limitations, NURBS modeling is a good example of how a digital tool that has really opened up has changed and have created new possibilities for new types of analysis creations. Now, I just want to make an important point regarding digital tools. So in order for us to be able to tackle this new level of formal complexity that the new digital technologies bring with them, a mastery of techniques and a natural creative ability have to be combined with a multi-layer knowledge of design complexity. This in turn require us to come up with innovative solutions of assembly that might not have been possible with the tools of the past. So it is only then that we can fully control these tools instead of letting these tools control all design outcome, as we mentioned before. So the digital era allows us designers to be precise in our intent to represent visual intelligence at many different scales. So these new techniques and methods now allows for the mediation of complexity in the many systems that we, the designers, have to deal with. In a sense, dealing with all this information in an elegant manner is a way of assembly and of organizing a massive amount of information. And then, this is a prototype here. I just wanted to mention the importance that we, as designers, like now, we have to not only design the object or the building, but come up with the assembly solutions, because most of the time contractors are, they don't know how to build it. So it's up to us to create mock-ups. So understanding that this is now part of the design process is important, because now we don't depend on new technologies anymore. Like every time a new technology comes along, we embrace it, and we know that we have to figure out the assembly process. So there's no, like, we can be at the forefront of design if we think that the assembly process is just as important. So just how do we start this assembly process? For me, the assembly process always starts with the diagram. So the diagram is a beginning for assembly and disassembly. Speaking of organizing great amounts of information, I want to talk a little bit about the importance of the diagram. Every project usually starts with the diagram in one way or another. However, the main lesson lies in understanding that diagrams are not to be used in a reductive way, but rather they should start to become abstract records of complex systems that guide the project or the composition. So there's no doubt that in order to control the multiplicity of forces which the architect deals with, the diagram has been the most helpful tool. Diagrams allows us to understand complex and underlying issues present in a particular site or project. When we diagram, we are without a doubt breaking down information so that we can understand the issues and opportunities present at a specific site or at a specific project. Only then we're able to reassemble this information into possible solutions for what the project or the site might need. In other words, the diagram is a two-dimensional assemblage of our own interpretation of the information that is present at any given moment. So understanding that the assembly process is not only physical, but also diagrammatic is an important part of understanding the entire design process. So diagrams allow for designers to produce solutions that are coherent to the continued fields and forces that generate fluidity and motion in design. Form and organization should not appear as a predetermined product from the outside, but it should be shaped by the invisible forces that constitute the true context of a project. Instead of minimizing complexity, good designers accept these intrinsic complications, and it's only through this acceptance that a disjunctive continuity comes to the surface. Ideas of non-linearity and emergence can be captured through the diagram. They capture not only these invisible forces, but they lead the design process from the conceptual stage all the way to emergence of architectural form. And so this is a parquet deformation that is pinpointing different stages of a specific project that I was diagramming at the time. But the main important thing is that diagrams can describe how a multiplicity of functional conditions can be read in spatial terms. So to form an actual structure eventually. So spatial scheme is transformed into architectural symbols by the customary planning method. And from this, a three-dimensional change is brought into effect. One which depends on the individual self-expression. Again, the idea of what's important to you as a cultural value. So self-expression is a big aspect of how we identify or how we interpret our own diagrams. So this is very important because it is one of the reasons why we ask you all to choose the images that have a great cultural value to you again. So the conventions of architecture play an influential role in planning and assembling a diagram. In other words, our own experiences within our own social circles and cultural spaces affect the way that we eventually diagram. So embracing our own cultural trajectories is key in developing something that transcends the normative. Only when diagramming is seen as an act of disassembling and reassembling information are we able to uncover a new rhythm of unfolding geometries that are able to provide the world with innovation. In a sense, design is nothing more than an uncovering of rhythmic patterns that are present everywhere, but that can be harvested only through a structuring diagram. They also have the potential to serve an explanatory function, clarifying form, structure, or program to the designers and to others. And notations map program in time and space. The primary utility of the diagram is as an abstract means of thinking about organization. The variables in an organizational diagram include both formal and programmatic configurations, space and event, force and resistance, density, distribution, and direction. In an architectural context, organization implies both program and its distribution of space, bypassing conventional dichotomies of function versus form or form versus content. So multiple functions and action over time are implicit in the diagram. The configurations it develops are momentary clusters of figures in space, subject to continual modification. The diagram is therefore not a thing in itself, but a description of potential relationships among elements. It is important that diagrams not only map or represent existing objects of systems, but they have the potential to also anticipate new organizations and specify new upcoming relationships. So transcending the diagram. Now, how do we do this, right? So Greg Ling once said something that is really interesting to me. He said that if we talk about non-digital tools, like a hammer, for example, it is very important to understand that it can be easily considered a dangerous weapon in the hands of a person that is not skilled with it. So in the same way, 3D modeling softwares and the techniques and methods mentioned before can be equally dangerous. Going back to the Renaissance, like the painters of that time who invested years mixing colors before they actually picked up a brush, today's designers will benefit greatly from understanding tectonics and methods of assemblies before manipulating these powerful 21st century hammers, in a sense. So in these compositions, there were things that were, they had good qualities and they were successful, and other qualities that were not. So this is why it's very important to create a feedback loop for yourself so that we can train ourselves and fine tune our own design process. So you can now produce something, step back, look at it, and evaluate if that production is meaningful to you based on your own cultural trajectory and things like that. So in today's design world, 3D modeling provides designers control over building systems so that complex shapes can be managed better than traditional forms using traditional design tools. Times are changing, and we are pioneers at the dawn of a new method of building that frees us from the rectangular world of 2x4 constructions. However, as extraordinary as these new tools are, we have to understand that they also come with an entire new challenge. Eliminating the need for 2x4s then requires replacing them with something new that might not be invented yet, right? So a new building material or a new type of construction. Creating a wall that curves requires that I-beams be modified to follow these new conditions, right? So the point is that this new freedom of design also presents challenges for designers if they do not develop an informed understanding of methods of assemblies and tectonics. So the fact that we come with advanced tools for design does not make complex buildings easier to design. They just make them possible, right? So the pressure and demands on designers of today who wield these tools is greater than ever before. Here is a series of shop drawings that I developed with Bingyu and Maria Sofia Garcia and Defenshi for a prototype of a design that we did for a concrete panel. So, you know, the fact that not only we need to think of the design, but also think of a way to fabricate it. And we should do this often because it trains us to not depend on the new technologies, right? We don't depend on an outsider to tell us how to build our own design. So we learn how to be at the forefront of design. So in the past, architects could rely on contractors to figure out the means and methods of assembly and construction, which is what I mentioned before. But today, architects are far ahead of most contractors, which is why it is so important that we learn how to break down our own designs into systems that can be assembled. This is where creating prototypes comes into place as a way for us to prove and show contractors the way in which things can be built, even if it has not been done before. Getting into this mindset opens up the possibility for us to be always open to the adaptation of these new technologies as a normal part of the design process, like we mentioned before. And then again, understanding that the process of assembly always starts before the physical object, even with the formwork, even with the drawings itself. So drawings are, for me, a big way of assembling ideas and testing them before actually taking them to the physical realm. So here are some details from this prototype for a corner condition utilizing the same reusable formwork designed for 2 8-foot concrete panels. And then now that we're here, we can actually have a conversation about part-to-whole relationships. With this mindset and understanding the advantages of new technologies, then we can look at part-to-whole ideologies. So as we know, everything in nature is made up of components. It starts from basic components like atoms and molecules, and it grows to bigger components like tissues and organs in order to construct a live body, right? So the artificial environment is quite the same. It all starts with basic components like points and lines, and they grow eventually to surface and finally construct a space. And keep this in mind because this is exactly the workflow that we're going to be following for our workshop, which is components, lines, then grows to surface, then finally construct objects or 3-dimensional objects. This is a close-up of our wall system that we designed for Rahim studio. And you know, an architecture of complexity and accommodation does not reject the whole. The whole is dependent on the position, number, and inherent characteristics of the parts. Venturi mentioned that the difficult whole in an architecture of complexity and contradiction includes multiplicity and diversity of elements in relationships that might look inconsistent, but are not. Concerning the positions of the parts, for instance, such an architecture encourages complex rhythms over simple ones. The difficult whole, as he called it, can include a diversity of directions as well. So this is a kit of parts, understanding that we do not produce buildings by 3D printing the entire thing, but we break them down and we analyze tolerances and scale problems and directional issues so that our composition can flow a little bit better. And also embracing the differences between these pieces. Like they're their own pieces on their own, but they form a whole when they're together. So that's really important to mention. Again, concerning the number of parts in a whole, the two extremes, a single part and a multiplicity of parts, read as a whole most easily. So the single part is itself a unity, and extreme multiplicity reads like a unity through a tendency of the parts to change scale and to be perceived as an overall pattern or texture. So think about this when coming up with your own compositions. Let's see. I had an assembly video here that I don't know if it's playing. Let me see if I can find it. There we go. So one second. So again, understanding that the process in itself, how parts fit together is the main aspect of the design process for us. We don't want to build everything at once, but we want to actually embrace the construction process, the assembly process, to create like a disjunctive continuity in the entire composition, right? So that was that video. So yeah, that video showed the assembly process of a composition that deals not only with part-to-whole ideologies, but also presents itself as a continuous jet disjunctive composition. And this is the final composition. And when I say final, it's quotation, because honestly, like this could be the beginning of so many different projects. Like when you develop your own kit of parts, as I see this, then you create your own tools for design, your own language that you can then utilize at different scales. Like this could be, you can operate at city scales, at furniture scale, at detail scale, because you already have kind of like a language that you develop from your diagrams, right? Let's go to the slideshow. So that's that. And now when we talk about part-to-whole relationships, we can focus on different instances, right? So the unit to whole, which this occurs when like there's a direct relationship between the unit and the whole. Like the pyramids are comprised of enormous quantities of stone blocks, right, and cladding pieces. Yet the dominant perception of this building or this composition is of an identifiable entity. It's a pyramid, right? It's a prism, but it's comprised of blocks, which is kind of interesting to look at. So that's units equal to whole. Then we have units contained in whole, which, in the relationship of units contained in the whole, the units are structural components, use spaces, or block of use spaces. The whole is the dominant image, with the units not expressed on the exteriors as much. So this is another different kind of like part-to-whole relationship. Then we have the whole greater than the sum of its units. So in this relationship, the whole incorporates more built form than that assigned to the identified units. So you can really look at the different, it's more like on aggregation design. So you can see the different forms coming together to form a unit, like a whole. So that's the whole greater than the sum of its units. And then units can be adjoining. This is the Flory building by James Sterling. The most prevalent form of unit to whole relationship is the aggregation of units to create the whole. To aggregate units is to put the units in proximity with each other so that some relationship is perceived to exist, right? And then we have units overlap. This is just an example of like how overlapping of volumes can create spatial connections. This is the Yale architecture building, a series of overlapping trays define interior spaces in this case. And then we can also have units separate, right? So this is the Yotogi National Stadium by Kenzo Tange. And units may be separate and at the same time related to other units to form a whole. Separation can occur through physical isolation or through the articulation of the connections between the units, such that the units are perceived to be separate. Units which are related to other units can be separate through isolation or articulation of the connection, right? So this is what's happening here. You can read this as a whole project, right? But the volumes are separate. And sometimes notations on the flat plane helps with separation and reading things as a whole. So your language, this is why it's so important to create your tool, your kit of parts from the 2D to the 3D, because when you have your volumetric parts, sometimes being utilizing notation in your same language in the 2D plane allows for your volumes to read like they work together, right? So, and then, I just want to mention that understanding part-to-whole relationships as well as assembly methods allows us to be able to come up with tectonic solutions at many different scales, right? So as designers, I encourage you all to think of everything as an assembly. We can think of many things as an assembly, like sketches, for example. We can, if we start treating sketches as an assembly, like how one line, you imagine this as a 3-dimensional object, right? But like it's a 2-dimensional plane. So like when you're designing this sketch or your own idea, you have to accommodate for the fact that this line is stopping here, but appears somewhere over here to turn the corners and give this idea of 3-dimensional volume. So understanding that you can assemble even in the 2-dimensional realm is important. So sketches are a good way of thinking of assembly that is not mentioned enough. So I wanted to bring that into the conversation. Again, this is a time lapse of like a sketch that I did, but you can see how you can start aggregating figures and they become more and more and they nest together. And you can start testing ideas before you actually fabricate anything, right? You can test ideas in the 2D realm, connections, articulations, and then this can be a top view, this can be a side plan, this can be a section, a plan. You can take figures from here and develop your 3-dimensional object. So I think in the same way of the detail wall, right? Sketches allows you to start there, just like the diagram. Diagrams do the same thing. So it's important to mention that. Again, this is, we can assemble strange objects, right? Understand the what is the order of operation? Do we have to move this piece first before this other piece nests into the main composition, right? Things like this are things that, add another layer of complexity to it. And I think that we should all take into consideration. This is another option. Again, playing again with this idea of part-to-whole relationship, how like figures nest together and they shy away from the extrusion. We don't want to depend on the extrusion as designers. So how do we create 3-dimensional objects that on their own, they're sculptural and they're beautiful and they serve a function, but then when they come together, they serve a completely different function, right? So thinking about this is also important. We can also think about furniture, right? This is Japanese joinery. How do we design furniture? How do things come together? The elegance of the material. What materials are we using? All of these things are part of the assembly process. And we as designers should aim to learn as much as possible from these construction methods, because this is a smaller scale of what we're going to be dealing with in terms of building construction, right? Facade panels. You can assemble from the small scale to the big scale. You can assemble small buildings. How do you consider, even if you're doing a design project, understanding that things don't happen just on the surface of a project, but things travel around the project. They're their own systems, their own organisms that make the building what it is, right? So understanding that everything is a system, treating everything as a system, it's important. And then how these things come together is also important, right? And then, yeah, this is the wall detail that we developed for Rahim Studio. Only by understanding all of this that I just mentioned, we can start having a final conversation about elegance in design, right? So once the tools and the techniques are controlled through coordination, the formal features allow for gracefulness and movement, right? Revealing precision and mastery that can be accomplished with specific techniques, with the goal of achieving a disjunctive continuity. To achieve a disjunctive continuity is to organize chaos. This happens through a creation of a group of formal elements that are distinctive, yet remain interrelated as they transform from one to another in an elegant composition that reads just as well as the sum of its parts and also as a whole. So I encourage you guys to not try to simplify complexity, but to embrace the complexity as constraint for your design process. Thank you very much. And so if we have any questions, we can jump to answering some of those questions. Let me stop sharing the screen. Is there any question?
Guys, feel free to ask any question. Oh, there's somebody asking a question. Yeah.
Okay, good.
Could we have some time to organize our words? Yes, yes, please.
Miguel, are you going to show them techniques and things like that from drawing into 2 and 3D today or no?
Yes, yes. We will be focusing on 2D for today because I
Okay,
think it's
great.
important for them to start drawing. It's very
Excellent.
important. Yeah. So we will take after the questions, we will take a small 10-minute break and then we'll come back for a small writing
excellent.
session on that.
Okay, great.
Yeah. Yeah. Yeah, maybe it helps if I share the screen again and go over the slides. Maybe looking at the images
Yeah.
helps in terms of remembering.
Right. Yeah, by the way, I'm preparing the mirror board for you all, so it should be sending you a link soon. So
My computer is really slow to share the screen and this is not the right screen.
okay.
All right, let's do it again.
Wonderful lecture, Miguel. It probably need a student needed to look at over and over to understand because there's so many information there.
Thank you. Thank you. Yeah, I know it can be overwhelming, but it's something that, you know, we eventually will do it so many times in our careers that I think it's important to.
Right.
No, it's not overwhelmed, but it's so rich that they really can learn a lot from this whole lecture.
Thank you. Thank you. Thank you.
10,000 hours to be an expert in anything, right? So
Yeah,
over and over
Yes.
is correct.
that's right. Yeah.
And I also especially love you show all this progress of your own project. Which
Yeah,
is
I
really
think
great. for
yeah,
students too.
I think it's important to not only like lecture, but to you know, walk the talk in a sense, like, you know, understanding this is what we do as architects and designers. So just it's part of the process. It is what it is. It's, you know, I embrace that and I love the entire assembly process. It is quite you know, when the project jumps from the digital to the physical realm, it's an extra layer of information and of like as academic, as a student, when you present your projects and you have a layer of a physical model that precedes your drawings, like now the project is real, right? You figure out how to assemble these figures that were on the 2D plane, and that's what that master is what people are appealed by that.
One important thing, I mean, everyone in this workshop should realize is that it's okay to make a mistake, but you've got to realize you've made a mistake, right? That's the trick. You've got to become self-critical. So, yes. I mean, I like that, you can work on something and feel that it's perfect, but yep. You have to realize that it can always be better, right? So yep. If we ask people to rethink or redo or, all of that is part of the learning process, right? The learning process is about iteration and doing it again and again and again. And, quite honestly, the more iterations you go through, the better the project always is.
Yeah, right. I definitely agree. That's why I wanted to include even this slide, which is...
I mean, I remember this slide is so early on, right? We just latched onto the left part, right? We said, look, forget about the right now. Let's work on the left one. And then, you went back and really teased out more information from it to grow the system. And I think that that's really an important lesson to learn, right?
Yeah.
But you guys were so bent on that. I remember, I mean, the discussions we had, you didn't want to give it up, but then slowly it became more and more refined, through the course of the class. So I think that's a very important, and if you look at that model versus the final project, I mean, there's no comparison, right?
Yeah.
And the final project is way better. So even if you're as talented as Miguel, which I'm sure you all are, I think that you just have to realize that the more you do it, the better it gets, right? And I think Bingyu went through exactly the same process. Right.
Yes.
So it's really very important to understand on every front. So when Bingyu was speaking about the osteogram image and how to just test different ideas and to develop particular thoughts deeper, that's how it happens. It comes through more and more trials. It doesn't happen in a vacuum.
Yeah.
In terms of the discipline today, you can't sit back and think about it. You've got to just do it, right?
Yeah. Yeah. So there's a couple of things that in the lecture I was talking about, which was that feedback loop. Just the technologies now allows us to produce things at so fast, right? But now it's up to us to take a step back and look at things and realize that they can have the value for certain things and not for other things. So how do we reproduce that same idea, but we refined it and we created new techniques based on that? So that feedback loop is important. And the other thing is that too, if we as designers already accept the assembly process as part of the design process and not just something that happens at the end, we're gonna always be at the front of technology, right? So we can learn new technologies easily because it's part of our design process already, which is interesting.
So your screen is still starting to sharing, but it's not sharing, right?
Oh, it's not sharing?
Or just me? I cannot see it.
No, I see it.
Okay.
I can say it.
Oh, okay, I cannot see it. Yeah. What if a student need the time to thinking further and compose their question, maybe we can just break for 10 minutes and then they can raise their question after the break?
Yeah, let's do that. Let's do 10 minutes and come back at 9:15.
Okay.
Right, that'd
okay.
be great. Thank you.
Sounds good.
All
Thank
right.
you.
See you guys.
See you.
See you.
Are we all back?
Yes.
Yes, here. Yes.
Nice. So I guess we can try to turn the cameras back on. I don't know if my internet is gonna die on me, but we can try that so that we can, it feels like we having a conversation.
By the way, Miguel, some student was asking question in the group chat, so maybe you can answer it. Yeah.
Yeah. So the history, the culture, and tectonic, and the elements associate closely. Finally, the outcome of your work is more like some kind of thick wall. Yes. The idea of the detail wall, which is what we're gonna be doing in the workshop, is more like a facade, kind of like with depth. But the main idea of this is the main point is to create a part-to-whole relationship and a disjunctive continuity model where your cultural pieces are present, but are not quite what we had at the beginning before we did the osteogram. So we're trying to estrange those figures to create something different. And then in the process, figure out how this new typology of figures go from the 2D to the 3D, but also how they come together, which is tricky. So through trial and error, we can figure it out together. But yeah, you're right. The idea is to create this thick facade in a sense. Yeah.
Hello, Professor.
Hi.
My question is a little difficult for me to ask you, but I try my best to organize my words and as a facade or a thick wall. I think it may contains the structure, the ornament, and the details.
Yes.
And it had to control the amount of the messages if you use it to construct a space or home. So I can't get it. During the workshop, what we will do in the last time, in the next time. So that's all.
Yeah, so I think the outcome of the workshop will be the detailed facade model that you saw at the end. But in the meantime, there's a process behind this. So we will go through diagramming your osteogram images to then going from the 2D plane to the 2.5D, which is the facade model. So and in this exercise, there's a lot of complexities that we will have to figure out. Like like you mentioned, the figures can be considered as structural elements because they start to hold each other to create this part-to-whole relationship. So we will be doing this, and like if you know, let me see.
Okay, so Miguel, maybe
Yes.
another way of also talking about this is if you put Na, can you say something? So you see her background. It's very important that your osteogram images reflect your interests as architects, right?
Yeah.
Because the aesthetics that are going to come out of those images. So you can control the images into interests that you have. So you can have a large range from ornamental, which I would say is Miguel's work, somewhere in the middle, which is probably Bingyu's work, or much more relaxed, which is more like Bash's work, right? So there's or Mira's work, right? So there's a big range there in terms of aesthetics. Yep. And I think you should stress that a little bit, because I don't, I mean, I love hyper intricate figures, right, that are intermingled. But that's not the only way of going. There are lots, but the assemblies and the ways they come together. I mean, I like the one you were showing also in the white model, which you took apart, Miguel. I think that's important because that has a completely different aesthetic, right? So
yeah, let me share
I think you should talk a little bit about controlling the aesthetic through the osteogram image, which then will go into kind of all the techniques and the drawings, etc. Right?
Yeah. So like the main reason why the other exercise that we do is like not to impose our own architectural style or influence into the design. So my project looks the way that it does because it comes from the analysis and it comes from the precision of my diagram from my osteogram, which, you know, if you look at it, it's way more figural. It's a different kind of condition than being used osteogram image, right? So another exercise that I think is important is to follow the process completely in terms of embracing what kind of cultural aspect you get from your image. So the osteogram image is an important first step. The next first step is the diagram on top of these images. How do we start extracting information from this? So that's what guided the final outcome of the project, right? So the idea that we don't know exactly what we're gonna get at the end. Like I didn't set out the first day of the studio to get something like this, but the fact that you trust the process and you figure out ways of extracting information from the 2D to the 3D is something that we will work on.
Yeah.
Yeah, maybe also I can explain a little bit by Chinese, just help you guys understand what both Miguel and Ali talk about the process of this workshop. 就是因为我觉得是这样的，首先就是我们第一要去 trust 这个过程，对吧？就是大家要按照我们的这个 workshop 的这样的一个告诉大家的每一个步骤去 follow 这个每个步骤，然后去从最开始这个 osteogram image。然后到这个我们的 2.5D symbol， 然后那这个过程中间呢，从一开始从 osteogram image 开始呢，我们大家就已经开始去寻找一些结合你自己文化背景和你自己这个所在城市的背景或你所喜欢的一些风格上的，比如说通过 style image， 而这些图片本身就已经有暗示一些aesthetic 的东西，对吧？暗示一些美学上的东西。那然后呢，接着我们因为通过这样的混合的 image 的过程呢，然后我们得到了一个新的 image。那这个新的 image 它是之前没有过的，但是呢，它同时包含了两种 image 的信息，还有你自己对于这两种 image 信息的思考。然后呢，我们把这个 image 然后去转化成一个2.5D 的这个装配模型，那这个过程就是也更需要你去有这个 design sensitivity， 然后通过这个设计的这个敏感度呢，也就是你要去发展你自己的这个 technique， 然后这个 technique 这个技巧会帮助你再一次的或者再深化的去转译图像到这个装配模型的过程。那这也是非常难的地方，也就是说大家需要不断的这个练习，从 image 开始就要不断练习，然后一直到这个建模的过程中也要不断练习。那最后呢，每一个人都会有不同的对于这个你的这个装配模型的 aesthetic。大家可以看到像这个这个我们之前在这个 poster 里面 show 的这个 4 different project， 对吧？4个不同的这个模型。那其实大家都是 follow the same process， 然后尽管甚至我们文化的背景我们都选用的是 Islamic architecture， 但是我们最后得到的结果 result is completely different， right？ 但那这个过程中，其实就是每个人对于文化，每个人对于 technique 的这个认知都会有不一样，每个人在这个练习的过程中都会得到不同的技巧。然后呢，那这些技巧可以帮助每个人最终得到非常不一样的这个装配模型。那这个装配模型当中的不同的 figure 其实都暗示着不同的cultural message， 对吧？文化上的信息，还有你个人的 technique， 所以它是一个，就像我们这个 lecture 说的，它是一个 technology、technique、aesthetic， 然后culture 这些所有这个不同 factor 的一个最终的一个这个表达。所以我觉得这个过程中，就是大家可以学到很多这个所谓什么是 design，right？
I don't know if there's any other questions that maybe they want to ask you, Bingyu, and then you can translate it for me. That also works.
Yeah. If you guys feel， 如果大家那个觉得这个是可以说中文，如果觉得说英文稍微，我可以帮大家去跟米高沟通。
In the meantime, this is the mirror board that we're gonna be using for the studio. So I would encourage all of you guys to start pinning up your Instagram results here as you go along, so that we can give you feedback even during the day, right? Because that's the first important step of the workshop. So we can give feedback if you guys already can access the mirror board. I don't know if you guys can. I had to send a permission link to Bingyu, so that's something that we have to look at.
Let me see my email.
So all the students need to send you email first to get the access, right?
I mean, no, actually, hey, Miguel, actually, I just, the reason why I share the link, because you can just click the link to access the
Oh,
board.
Okay.
Yeah, so the link, like,
this is access and they can upload.
Yes, they can upload their image. Yes.
So yeah, I can see Bingyu there now. So the first time they click the link, Bingyu gets a notification, and then they can get the access. So we got 10 teams, which is good. So maybe is there any groups that have already a first pass of their Instagram images that we can see here, so that we can give feedback before we jump into the tracing, kind of like diagramming to the image?
Yeah. 大家有没有谁尝试做过这个基于第一个 lecture 做过这个 Oscar image， 可以去把这个 image post 到这个 mirror board 上。
I think everybody still need a time to understand how mirror board work and register.
I mean, you can just like.
Well, I 2 years ago, so I probably they need a little time to know it.
That's fine. That's fine.
Yeah.
So maybe I can go over some of the diagramming techniques. So I have my Rhino open here. So main important thing is, just bring in your images, use layers, be organized. That's very important. So if we start with our image, right? There's a couple of commands that I want you guys to understand.
Miguel,
I think your
screen.
Yeah, I think I'm sharing your email right now. Yeah.
Oh my God. Okay. Here. Let's see. You see it? Yeah.
Now we can see it. Yeah.
Okay, perfect. So, just understanding how to bring the image. Usually you use the command picture, and you can look for your image and bring it into Rhino, put it in a layer, lock it, and then you can get to work on that. The main thing that I want to stress enough, like if you see this, that looks like a mess, it's actually control underlying geometry that we use to have better 2D geometry, if that makes sense. So we can start using commands. The main important thing is we don't want to do this. This is not acceptable. if you click the curve, you see how many different control points this curve has versus something that's more like we can achieve the same thing by drawing the curve and then finding tangents of, and then we can control here how much of the tangent we want to do, right? So just going a little bit quick just to show the difference between these two curves when we finish, because this becomes a whole process that damages your modeling at the end. So let's just join this. So if you see the control points from this curve, it's more close to the actual shape that we want versus these control points, which are all the way out there, right? So the same thing when we extrude this, you get more of these divisions. That's okay. Sometimes this might give you the same thing, but I think like in terms of geometric language, this is more control than just randomizing your curves. So first thing we want to do is we want to stay away from this kind of curve and get closer to this one. So as a first step, you always bring your image in. I would recommend creating a layer for underlying geometry, like you can call it underlying or normative geometry. And then we can go to that layer. If you put preview on, it can show line weight. It can show color. So I would use that as a way to not have everything read the same, right? You know, so the way you do that is you change the thickness here of your line. In this case, I want that to be like default thickness because it's going to be the underlying geometry. But I want it to be not continuous line. I want it to be a dash line. So you can choose from here your dash lines, and then we can start drawing. So we got circles, and the main thing is that the one that we all know is the center to radius, right? So you can start looking at your geometry in that way. Another command, important, offset. Then you can choose distance from your offset to the specific distance that we want. I guess we want to have this little lip from that circle. So we can start doing that, right? So something else that I want to show you is if we have another tangent over here, let's say I want to draw this curve. There's a drop-down menu here that we can use, which is the circle tangent to 3 curves, which is one of the commands that I use the most because it allows you to click on the edge of that figure and it will create the precise diameter for your figure, right? So now you can be precise in terms of like, okay, and now I need to follow this curve, right? How do I do that? So if you click on the tangent to 3 curves, you can click on your existing circle and then on the second point and then on your last circle. So now you start to connect your figures in a control way and then you can trim, right? I will leave this as my geometry that's underlined and create a new layer for my actual drawing. I can call it figures, drawing, and then here we can change the thickness again. Something that we can see, let's see. We're still in the same layer. So you can, if you need to change layers, you can either match layer, command match layer, and we can match this one and it will change it to that. Or we can click here and in the drop-down menu here, you have your layers. So I'm just gonna put it in line 1. And that looks okay. So now what I can do is I can copy this, like copy, enter in place. It will copy everything in the same place. So now I have double lines there. So I want to lock the one that I just did so I can work on the other ones. Now, from the other ones, I can change it to my layer, right? They become solid lines. And now I can start drawing. I can start trimming this circle, right? And it will give me now that curve until it got to this point, but it still keeps my underlying geometry, because I think it's important to also understand and respect your underlying geometry so that you can be a little bit more control in terms of that. Different commands, you can use it. You can use this command that's called under the line. You can have the tangent from curve, which is like allows you to always pick just the tangent to tangent, right? So you now can start drawing, instead of drawing this, right? Now you can be more precise in the way that you turn corners and things like that. So now you can trim this guy and have that connection there. So, we want to avoid things like this as well. So like when you have moments like this, I will rebuild them with your whatever kind of like tangent you want. So the main command that I want to stress is this guy. So circle tangent to 3 curves would allow you to control the way that you model in 2D, and now you can start having more kind of like control geometry. There's a couple of commands that we want to use, or you might end up using, which is twin curves, which is it will find the in between these 2 curves. So like if I have this curve and I have this other one, but I need to find a one in between, right? So you can do twin curves, select the start and the end curve, and it will start, like sometimes it does this, you can click here to rearrange it, and it will give you the exact middle. If you have it at 1, it will find the exact middle between those 2 curves. You can add more, and this is a good technique for really complex drawings. You can use this, like 100 will give you something like this, like it will give you texture. So going back to my histogram image, right? How would I draw something like this big figure? Like the way that I analyze this is in terms of like what gives me the more depth. So let's say I want to draw that, right? So I'll go back to my underlying geometry, and we can start clicking on the tangent of that figure to kind of like come up with the solution. Sometimes you see that this deviates, but that's just because there's another tangent that we haven't constructed. So we can now, again, click there and connect those 2. So when we trim, so like if I do copy in place and I lock that, we can change this now to line 1. Right now they're solid. I can now, let's see, I want to leave it until that point so I can trim. So I can now trim, let me just put a point here so that my line doesn't go away completely. I can trim this and it will now follow. Now we'll have the curve that we want, right? And it looks like it is in control, but it's not. It follows tangents every single moment. So this is what we want you guys to be precise about, right? Look at the moments where you see depth or you see interesting moments. So for the first exercise, what we want you guys to do is to focus on 3 or 4 areas of your drawing. Don't focus on the entire composition. Just, for example, I find this moment quite appealing. So I'm just gonna trace this moment and maybe I'll zoom in here and I wanna try to figure out this moment. So we want you guys to also tell us where are you guys focusing in terms of your drawings and try to only trace that. Like the more that you can trace, the better. Start with 5 areas of your drawing. Then if you have more time, continue drawing the rest of your histogram image. But definitely look at moments like this. For example, this looks like it's overlapping. So how do we trace that control? And then eventually we will take this to the 2.5D realm. So first step, focus on areas on your histogram image and try to draw that precisely. Is there any question in terms of that?
Oh, by the way, also the reason Miguel mentioned and the reason why we use the Euclidean geometry. I mean, the Euclidean geometry in Chinese means 欧几米德几何, right? Like we use a lot of arc to represent the to replace the free curve. The reason why we're doing that, because that also helps your process for 3D modeling. Like when you create a surface condition, if you do like a loft between like free curve, usually give you really twisted and deformed surface. But the Euclidean arc can give you much cleaner surface that can be easily constructed, even for the 3D printer, right? Sometimes 3D printer cannot print something, you know, like twisted surface. It give you like the edges on the surface is very bad, but Euclidean geometry can give you much cleaner surface, very smoothly connected with the other surface. So that's the reason why we use the Euclidean geometry many times.
Yeah. So that it goes back to, again, methods of construction of tectonics. Every design that you want to build becomes 10 times easier if you build it out of developable surfaces. So developable surfaces are surfaces that are created with curves that are Euclidean geometry or normative geometry. So that's a good practice to have right now. It's just to always draw with precision, because being dirty in your curves would eventually make your surfaces dirtier than your volumes dirtier. So when you try to Boolean union something or Boolean difference, things will Boolean together. So it all starts from the 2D. So let's be intentional in the way that we draw that. Draw every single little detail that you find appealing to you in the image. Like, how do we imagine, like, I see this coming out of the image, so like I really want to focus on the outer one, but also there's a middle one that I can find here, and there's an interior one that's there. So now those are my 3 lines that kind of like give me that composition. Then eventually there's a step that's going to come, but where we're going to move to the 2.5D eventually. So we want you guys to be intentional in drawing every single detail that you think looks appealing to you 3D-dimensionally, that shows depth, that's a nice composition, and focus on a couple of them to model. Eventually we'll go over some modeling techniques. For now, it's just drawings and 2D, and continue revising your osteogram image. So if you want feedback, I would suggest as soon as you create your images, just upload them to the Miro board so that we can all look at it and give you feedback. Then this steps comes next. Okay. Any other questions? Any questions about commands in Rhino that we might use? I might be skipping maybe some of them. What else? What else? Basically, everything is here between these 2 drop downs, at least for me. The way that I draw, like if I want to do a rectangle to call out the places, then it's a rectangle, right? But main idea, create your layers. I think it will be interesting to see this drawing as an actual drawing eventually, so that you guys can have it also. So because you're gonna do it, right? You're gonna draw this thing, so might as well just show us inline drawing. So we will go over when the time comes to like how to export it to Illustrator and get right line weights and things like that, so that we can evaluate these drawings on their own. So that's that from me. I'm gonna stop sharing the screen and then maybe open up to questions one more time. And
Okay, so one student had a question on the group chat.
I see. Can it be understood as choosing a complex and beautiful picture first and then deconstructing the graphic plane? Yes and no, in the sense that depends on what what your parameters for considering something beautiful is. So like in terms of what we want to look for the image, is like moments that showcase a sense of depth, geometry that's quite intricate or interesting, things that look like they're overlapping or happening behind another figures. So that's what I would consider beautiful in terms of like the qualities of the image that I will be pursuing for. Because beautiful is such a general word that, but yes. So let's look at compelling images first, and then we will be extracting information from the graphic plane.
You mean the osteogram images, right?
Yes.
You don't need compelling initial images.
Yes.
So,
no.
Right. The other thing is that qualities are important, right? So if you've got to have 3 different qualities in your image, so you may want to describe what a quality is. Qualities range from not only formal qualities, which would be sharpness or circular, right? The formal descriptions of the actual image, but the quality of soft, smooth, silky, textured, all of these kinds of qualities are really important as well. So if you can combine and have 3 formal qualities and 3 qualities, material qualities, then you've got enough for a beautiful project. That's how I describe beauty with regards to this workshop.
Yeah.
All right, well, if there's no other questions, we can wait a little bit longer, but again, the Miro board is available to you all. So start producing your images and then let's just upload it there so that we can take a look at them during the day.
Yeah, and then we can make notes on the board. So during we're sleeping, you guys can follow some notes like we have prepared for you.
Yeah. And we can always, we're always available through WeChat now. So like you can send any questions either in Chinese or English, and we can answer for you if you have questions. You can also send updates and things like that if you're having doubts about your project.
Yeah.
And starting Monday morning, we start 8 to 11 twice a day, right? 8 to 11,
Yes.
8 to 11. Okay.
Yeah, so I think I would encourage you guys to like take maybe a day to develop the images and give a first pass at drawing the information for Monday so that we can already hit the ground running and just give you feedback on that.
Yeah, you don't need, you don't need to draw like the whole, you don't need to trace whole images. Maybe just find some moments that are really interesting in your image and just draw that things very detailedly. And so, even the image is not the final image, but we still can like give you some advice suggestion for how you draw them like more delicately,
All right, if there's no more questions, I think we can stop it here. Send us any questions that you guys have through WeChat. And I look forward to seeing your Instagram images on Monday.
Yeah, looking forward to see you guys. Mhm.
Thank you so much. Thank you, Ali, for joining. Thank you, Na.
Thank you.
We'll see you
Thanks.
next time.
See you.
Bye.
Yeah.
See you on Monday. I mean, yeah, Beijing time.
Good job. Good job, Miguel.
Bye.
Good job,
Thanks.
good job.
Thanks.
Bye.
Bye.
Take care. Bye-bye.